Hi, my name is Austin Stottlemyre and I'm the team lead for the OkState 2019 Capstone group. So as you can see on the screen, this is our ConOps, our plan of attack for this Argonia competition. Per the rules, we will be launching our payload from a rocket, achieving an altitude of 8,000 feet AGL. Once we hit that apogee, we're going to release our glider, which is integrated with our nose cone. It will have an autopilot inside that guides itself back down to the target determined by the cloudbusters.
This is our rocket for the Argonia Cup Design Challenge. It's 84 inches in length and 21 pounds. It features an Onyx 3D printed nose cone that is going to double for the nose cone as the rocket as well as for our glider. Onyx is essentially a blend of nylon and carbon fiber. We purchased commercially fabricated tubes for our rocket that are 4 inches in diameter. We cut those down to our appropriate size and length with a chop saw. We feature a 14-inch eBay right here. We printed off the electronic housing that's featured here out of PLA. At the base of the rocket, we have our fins that were cut using a shear machine. We purchased fiberglass sheets to cut those with. We held those in place as well as the motor mount with a rock epoxy, and we are using an Aeropack motor retainer.
So the motor we're going to be using is a Cicerone L1350. It's a 3-grain 75mm motor, and it will provide us with 300 pounds of thrust, 4,280 newton-seconds of impulse, and it will coast our rocket up to about 10,000 feet with a max speed of Mach 1.15.
Hi, I'm Carter, and here's the design for our glider. As you can see, we got the nose cone at the front. This will also be the nose cone for our rocket. It's held in place with aluminum fasteners. And then we've got a 1.25 by 1.25 steel tube or aluminum tube. It's 8 inches long. It will be placed partly inside the nose cone. It'll be held together using barrels and screws. And then we've got deployable wings that were purchased helicopter blades and then cut down to size for a total of 44-inch span. And then we're holding that together with a steel pin, which is holding in 2 springs that will launch the wings. And then connected to that steel tube, or the aluminum tube, we have an aluminum T-bar, which is 1 inch by 1 inch, and that's held on to the aluminum tube with pull rivets on the bottom. And then for our control surfaces on the tail, we used sheeted fiberglass that we cut in-house.
This is the inside of our nose cone. Here in the front here we have our flight controller and all of our instruments. These will work together to guide the glider back to the landing zone. In the front we'll have the golf ball mounted inside foam so it does not move and damage the other flight instruments.
So that was our design for the 2019 Argonia Cup competition. We look forward to seeing you out on the flight field, and remember, go Pokes!
All the second stage tanks now pressurized. 35 seconds and counting. We are still go 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1.
A lot of wobble.
Straight up. And it's gone.
Oh my gosh.
Oh my God, where'd it go?